guys, today's lesson is on the first section of chapter 5. We're going to be dealing with different operations with polynomials this chapter, and the first section here we're going to talk specifically about exponent rules when doing some operations with polynomials. The first one we're going to discuss is multiplying or multiplication. When you're multiplying polynomials by or to each other, what you're going to do with variables that have exponents is you're going to add the exponents. So for example, problem number 1, both of those monomials, they both are one term, have the variable x in it. So to multiply like variables, we'll add their exponents. 4 plus 3 will give us 7, so x to the 4th times x cubed is x to the 7th. Moving on to problem number 2, we have two variables. We can multiply x together. Notice that this first x doesn't have an exponent. However, since it is present, we know that it will have an exponent of 1. Therefore, we can multiply the x's. X to the 1st times x cubed will be x to the 4th. 1 plus 3 is 4. And then we can multiply the y's. Y to the 4th times y to the 1st will be y to the 5th. Moving on to problem number 3, as you can see, now we have coefficients. When you have coefficients in any problem, you're going to do whatever the operation is that they're asking us of. So for problem number 3 is multiplying, so we will multiply the coefficients. 2 times negative 3 is negative 6. We'll multiply the x's. X to the 5th times x will be x to the 6th. And as you can see, there's no y in this term to multiply with this y, therefore we just remain having y to the 1st in our answer. Our next 3 problems, we're going to have one term possibly by multiple terms or 2 times terms by 2 terms. In this case, we're going to distribute. So in problem number 4, we'll distribute the x times each of the terms in the parentheses. The polynomial inside the parentheses is called a trinomial since there are 3 terms. X times x squared will be x cubed. Again, if we have a variable with no exponent, we consider that exponent to be 1. X times 3x will be 3x squared. And x times negative 1 is negative x. Similar to number 4, number 5, again, we're also just distributing one term that's called a monomial times all 3 terms inside the parentheses. That polynomial will be called a trinomial. Y squared times 2y is 2y cubed. The y squared technically has a coefficient of 1. So when we multiply the coefficients together, 1 times 2 is 2. Y squared times y to the 1st is y cubed. Distributing y squared to 3x would be 3xy squared. Since the variables aren't the same there, we can't multiply them together, nor would we add their exponents. And lastly, y squared times 1. Anything times 1 would be itself, so we would finish up by writing the last term, y squared. And lastly, number 6, we have 2 terms times 2 terms. We're going to FOIL or double distribute. I'm going to distribute the x times both of the terms in the second polynomial. Since there's 2 terms, this is a binomial times a binomial. X times x gives us x squared. X times y is just xy since they're not like variables. I'm now going to also distribute the y times the second binomial. Y times x, again xy, and y times y is y squared. In this case, we happen to have like terms left over, which are in the middle. These 2 terms are like terms because they have the same variables with the same exponents. X to the 1st and y to the 1st. How many terms of xy do we have? We have 2 of them. Therefore, our final answer would be x squared plus 2xy plus y squared. The next operation we're going to discuss is division. Multiplication, we add exponents to like variables, and division, we're going to subtract exponents to like variables. Problems 1, 2, and 3, again, we're just going to simply subtract the exponents of like variables when dividing. X to the 6 divided by x squared, 6 minus 2 would be x to the 4th. And we're always subtracting the numerator exponent minus the denominator exponent. The top exponent minus the bottom exponent. In problem number 2, as you can see, we have coefficients here. We're not going to subtract those, we're going to divide them. With coefficients, you do whatever operation they're asking us to do. 4 divided by 2 is 2. And then I'll divide the x's. X to the 6 divided by x to the 1st is x to the 5th. Lastly, problem number 3, we have two variables. We could only subtract exponents to the same variable. In the numerator, we have a coefficient of 3, and in the denominator, we don't have a coefficient. If there isn't a coefficient in the denominator, we could assume that it's 1. So here, when we divide the coefficients, it's like dividing 3 divided by 1 is 3. We'll now divide the x's by subtracting the exponents. X to the 4th divided by x squared is x squared. 4 minus 2 is 2. And lastly, y squared divided by y squared. 2 minus 2 is 0. You're never going to write y to the 0 power or anything to the 0 power in your answer. That value is actually 1. Something divided by itself is 1, and we're going to discuss that further in a section yet to come. In the description of division, it also says that we're never going to leave negative exponents in our answer. When we have a negative exponent, we are going to basically simplify the expression so that that exponent is positive. In problem number 4 and 5, I'm pretty much just showing you guys when the exponent is negative in the numerator, what to do with it, and in number 5, if the exponent is in the denominator and negative, what to do with it. We're basically taking the reciprocal of this expression in order to make the numerator positive. For example, problem number 4, the exponent is negative and it's in the numerator. If I were to make that a fraction, I could put it over 1. In order to make it positive, we're going to take the variable and the negative exponent and just flip-flop it. If it's in the numerator, we'll put it in the denominator to make it positive, and if it's in the denominator, we'll put it in the numerator. In this case, the x squared goes to the denominator to make the exponent positive, and what would be left in the numerator is the coefficient of 1. Just the opposite, problem number 5, as you can see, this is already a fraction, and the variable with the negative exponent is in the denominator. We're going to move it up to the numerator to make it positive. In the numerator, we'll have x to the positive 3rd exponent. The point of this is making the exponent positive, and what would be left in the denominator would be 1. We wouldn't leave it as an expression over 1. We would just say that that would be x cubed. From now on, when you do a division problem, if you just so happen to have a negative exponent in your answer, you will then have to fix it in order for it to be positive. We could further simplify it. So let's go divide problem number 6. As you can see, there's two variables. We'll do x first. X cubed divided by x is x squared, since 3 minus 1 is 2. And when we divide the y's, 4 minus 5 is negative 1. We will not leave this as our answer. The variable that has a negative exponent is y. So what we're going to do is take that variable and the exponent and bring it down to the denominator. What would be left in the numerator is the x squared. That's not going to move since its exponent is already positive. And in the denominator, we moved y down. We're not going to write y to the positive first, anything to the first is just itself, so it's just x squared divided by y. The third operation we're going to discuss is a power of a power. That is when we have an expression that might have a variable in it that's raised to another power or another exponent. This is when an exponent is raised to an exponent, and what we're going to do with them is multiply the exponents. As you could see in problem number 1, x squared is being raised to the 4th. The power of 2 is being raised to a power of 4. We're going to multiply them, and our answer would be x to the 8th. In problem number 2, we have two variables, x and y, in which we will multiply their exponents to the second power, or by 2. However, the coefficient out front, just like when multiplying or dividing, we're not going to multiply 3 times the power of 2. Since the 3 is a coefficient, we're going to raise it. We're going to do that operation. 3 squared is 3 times 3, which is 9. X squared squared, we're going to multiply the exponents. 2 times 2 is 4. And then y to the negative 4th squared would be y to the negative 8th. Just like the last section, as you could see, we have a negative exponent. We're not going to leave our answer like that. We're going to take the variable with the negative exponent and drop it to the denominator. What would be left in the numerator is 9x to the 4th divided by y to the 8th. The power of 8 is now positive. Since we dropped it down to the denominator, that was the point of doing so. We never want to leave a negative exponent in our answer. And lastly, problem number 3, negative 2 cubed is multiplying negative 2 times itself 3 times. Negative 2 times negative 2 is positive 4, times negative 2 gives us negative 8. X cubed would be x cubed. That exponent is 1 times 3, which is 3. And y to the negative 1st cubed would be y to the negative 3rd. We're going to take the variable that has a negative exponent and drop it to the denominator. You're always going to wait until the answer to see if you have a negative exponent left over. We will be dividing by y to the positive 3rd. The last operation that we're going to kind of go over, as before I mentioned that anything with a power of 0, the value of it is 1. If you took your calculator and raised any number in the world to the power or exponent of 0, the value is 1. That holds true to variables and expressions. So in problem number 1, we have 2 times x squared times y to the 0. We'll never have a negative exponent in our answer or an exponent of 0. Anything with an exponent of 0, we will simplify to 1, in which this expression is just 2 times x squared times 1. We wouldn't actually write in the times 1. This expression is just 2x squared. In problem number 2, notice that whole expression inside the parentheses is being raised to the 0 power. Therefore, this entire expression is equal to 1. And problem number 3 is a multiplication problem. However, again, we have y to the 0 power, which is really 1. So we're going to simplify this operation as 3x squared y times 2x, and then multiply. Multiplying the coefficients, 3 times 2 is 6. Multiplying like variables, x squared times x is x cubed. Y times, there's no y in the second expression to multiply it with, so we'll just write y in our answer. In the next section here, we have mixed operations, basically mixing up all the operations we talked about in the first page with exponents. When we multiply, we add the exponents. Division, we divide. Power to a power, we multiply the exponents. And in our answer, we'll never have an exponent of 0 or -1. Now we're going to combine a couple of those operations and write our answer as the most simplified expression we can. In problem number 1, notice that everything inside the parentheses is being raised to the second power. Therefore, we're going to raise everything to the second power, and then we will divide to simplify our answer. I'm going to start in the numerator. 2 to the second power would be 4. X cubed to the second power, we're going to multiply, is x to the 6th. And z to the 5th to the second power will be z to the 10th. I'm going to move down to the denominator and square everything there. 4 squared is 4 times 4 or 16. X to the 4th squared is x to the 8th. And lastly, z cubed squared will be z to the 6th. Now that I raised everything to the second power, we can now divide. 4/16 is going to be 1/4. We could simplify that. X to the 6th divided by x to the 8th. 6 minus 8 is -2. And z to the 10th divided by z to the 6th is z to the +4th. As you can see, we have a fraction in front and a negative exponent. Another way that we could write this as just one fraction instead of a fraction in front is actually multiplying 1/4 times x to the -2 z to the 4th would just be x to the -2nd z to the 4th over 4. As you can see, our x variable has a negative exponent, so we will put it in the denominator to make it positive. Z to the 4th would be left in the numerator, and in the denominator we'll have 4x to the +2nd. We will only move the variable that happens to have a negative exponent. Problem number 2 is a combination of multiplying and power of a power. What expression in number 2 is being raised to the second power? It's only the expression inside the parentheses. So what we're going to do is simplify this second half, and then we'll multiply by 2x. Squaring everything inside the parentheses, 3 squared is going to give us 9. X squared is going to give us x to the 4th power. Now that we squared everything inside the parentheses, we can multiply the two expressions that are left. 2 times 9 is 18. X times x to the 4th is x to the 5th. Last one in this row. The numerator is being raised to the 0 power, everything inside the parentheses. What does anything raised to the 0 power equal? That would be 1. Therefore, this expression actually simplifies to 1 divided by 3x squared y to the -1st. There's nothing left to divide in this case. There are no like variables in the numerator and denominator. However, one thing we do have to take care of is this negative exponent. Since it's in the denominator, we're going to move it to the numerator in order to make it positive. Therefore, in the numerator, we'll have 1y, and in the denominator, we'll have the 3x squared left over. What I'm going to ask you guys to do is pause the video, try problems 4, 5, and 6, and then play the video back for your answer. Here are your answers to problem 4, 5, and 6. Problem 4, we have two expressions being raised to the second power being multiplied to each other. So the first thing you want to do is square everything in both of the parentheses and then multiply the expressions that are left over. When you multiply the y squared times y to the -2nd, you would get y to the 0, since 2 plus -2 is 0. However, you wouldn't leave that in your answer, as that value would be 1. In problem number 5, again, dividing first, -4 divided by -2 is 2. X to the 0 divided by x would be x to the -1st. Y divided by y would be y to the 0. And z to the -1st divided by z would be z to the -2nd. We know y to the 0, the value of it is 1. And we would then move the x and the z both down to the denominator since they both have a negative exponent. And lastly, problem number 6, we could raise the second term to the 4th, getting x squared times x to the -4th times 1. Multiplying will give us x to the -2nd, and we never want to leave a negative exponent. Therefore, we would drop this down to the denominator, finding its reciprocal to make its exponent positive. The last operation we'll discuss is adding and subtracting. When you're adding and subtracting polynomials, you are just combining like terms. Like terms have the same variable with the same exponents. X squared plus 3x squared is going to give us 4x squared. We are combining how many like terms there are. In adding and subtracting, you are not changing the exponents. We are just combining the coefficients. In problem number 2, 3z minus 4z will give us -1z, in which we would just write as -z. And in problem number 3, we now have 2 terms plus 2 terms. Notice the operation in the middle of the parentheses. We're going to only combine like terms if there are any. 3x squared plus 2x squared we could combine. Those are like terms to give us 5x squared. Y plus, is there an like term in the second polynomial for y, or another term that has a y to the first in it? No, therefore that's like y plus nothing is y. And the only other term in this case that we have not combined with something else is the -5. Since there's no like terms in the first set of parentheses or terms with -5, it's like 0 plus -5 is -5. What I'm going to do is ask you to pause the video, try problems number 4 and 5. Once you get your answer, play the video back to check. Here are your answers for problem number 4 and 5. Combining your like terms in 4, our like terms are 2x squared and 3x squared, and the operation that we're combining them with is subtracting, leaving us with -x squared. Moving on to the next term, -x minus 2x, those are the terms that are like terms, is going to give us +1x. And lastly, 3 minus -5, please make sure you pay attention to your signs, will give us +8. Problem number 5, we're combining with addition here. 3y plus -y will give us 2y. 4z plus -4z cancel each other out, and make sure you combine all terms and represent them in your answer. We still haven't combined x in the second trinomial there with any term in the first. Therefore, it's like adding 0 plus x, which will give us x. Traditionally, we write our answer in alphabetical order with the variables. Our last page here is just giving us some information about polynomials. Polynomial names, which we should all be familiar with, that have 1 term are called monomials. 2 terms are called binomials. 3 terms are called trinomials. And polynomials with 4 or more terms are just called polynomials. Moving down to the bottom, we're talking about the degree of a monomial and then the degree of any other polynomial with more than 1 term. When we're finding the degree of a monomial, 1 term in this section, we're just adding all of the exponents for all of the variables. So The degree for problem number 1 is 1, since the only variable is x and the only exponent would be 1. In problem number 2, we have two variables. The degree would be adding their exponents. 4 plus 2 gives us the degree of 6. Problem number 3, we have three variables, x, y, and z. Adding all of their exponents, 2 plus 3 is 5, plus the exponent of 1 for the z will give us a degree of 6. When we have more than one term, finding the degree is very similar, however, it's just a little bit different. We're going to find the greatest degree of any term in the polynomial. So we're going to find the degree of each term as we did in the last section, and the greatest degree will be the degree for the entire polynomial, no matter how many terms it has. For example, problem number 1 is called a binomial because there are two terms. The degree for the first term is 2, the degree for the second term is 1. The greatest degree we found is 2, therefore that is the degree for the entire binomial. Problem number 2 is a trinomial because there are three terms. Let's find the degree of each individual term. The degree for the first term is 5. The degree for the second term is 3. 2 plus 1 is 3. And the degree for the third term is 7. Since 7 is the greatest degree we found, that is the degree for the entire trinomial. The last polynomial has 4 terms here. Let's find the degree of each. Since a is the only variable in the first term and it has an exponent of 1, the degree for the first term is 1. The degree for the second term is 2, adding the exponents. The degree for the third term is 3, 2 plus 1 is 3. And the degree for the last term, since it doesn't have a variable, would be 0. The greatest degree we found was 3, therefore that would be the degree for the entire polynomial. Please let me know if you have any questions on the lesson.